What if astronomer and science communicator Carl Sagan was also a CISO? In discussing the large-scale structure of the cosmos, astronomers sometimes say that space is curved, or that the number of volns is finite but unbounded, and that among these billions and billions of volns there may be intelligence. But how shall we discover intelligent life? Is it looking to CWEs, giving CVSS scores more decimal points? Should our lists go to 100 instead of 10? Perhaps the answer lies elsewhere, and that the paths of evolution will take AppSec in marvelous different directions. Which means this week we chat with Kelly Shortridge about resilience and what emerges from security chaos engineering. No news this week. Instead, we'll share 2 interviews from this year's RSA conference. Look to the stars and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. Your organization is building and updating business-critical web applications faster than ever. And with so much pressure to move fast, you may find yourself making trade-offs between innovation and security. Now you can build fast without sacrificing security with Invicti, the zero-noise application security platform that helps your dev, sec, and ops teams work together to secure every website, web app, and API. With unparalleled accuracy, coverage, and automation, Invicti scales like no other AppSec solution. Invicti, AppSec with zero noise. Visit securityweekly.com/Invicti. Struggling to secure all your applications with modern identity services? You're not alone. But with identity orchestration, you can say goodbye to refactoring and complexity. Strata Identity helps you modernize app identity at scale while mitigating security risks and simplifying policy management. Maintain a consistent security posture and simplify policy management with identity orchestration. If you're ready to simplify your identity environment and improve your app security, share your IAM challenge with the Strata team to get a brand new set of earbuds. Just visit securityweekly.com/strata to learn more. That's securityweekly.com/strata.
This is episode 240, recorded May 8th, 2023, and recorded with new music for the intro. Let us know what you think. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
On the new music, and I have to say, if I see someone doing a top 100 list, I'm coming for you.
It's orders of magnitude better, John. It could be 10 times 10. The other reason you could come for us if you don't join us at the upcoming official cybersecurity summit in a city near you. This series of one-day, invitation-only executive-level conferences are designed to educate senior cyber professionals on the latest threat landscape. We're pleased to offer our listeners $100. There's that number again, John. Off admission when you use code SECWEEK23 to register. Visit securityweekly.com/cybersecurity summit to learn more and register today. Kelly Shortridge is a senior principal engineer at Fastly in the office of the CTO and lead author of Security Chaos Engineering. Shortridge is best known for their work on resilience in complex software systems, the application of behavioral economics to cybersecurity, and bringing security out of the dark ages. Shortridge has been a successful enterprise product leader as well as a startup founder and investment banker. They frequently advise Fortune 500s, investors, startups, and federal agencies, and have spoken at major technology conferences. Shortridge's research has been featured in ACM, IEEE, and Usenix. They also serve on the editorial board of ACMQ. Hello, Kelly.
Hello.
Thank you for joining us.
Yeah, thank you so much for having me.
So we're very happy to have you here because Cosmos, which I sort of kicked off with, which Carl Sagan is famous for, comes from the Greek word for order. But you, Kelly, you're bringing us chaos,
Yes.
which I believe comes from the Greek word for software, if I'm not mistaken. But you're also talking about resiliency. Tell us about that word first.
Yes, I actually think it's interesting. There is some order in the cosmos, of course, but there's also a lot of chaos. There are lots of baffling interactions and strange things happening all the time, and that's true in any sort of complex system. So with resilience, the idea is really that we have to embrace this kind of messy, complex reality that failure is inevitable, and actually failure is happening all the time. So we need to be able to respond to failure gracefully and then adapt to evolving conditions. Because again, even we see in the heavens, things are changing all the time, and we have to be able to adapt to that and keep up.
And those failures, software has bugs. Every engineer is dealing with bugs. They have SEV, they have postmortems. It's when those bugs become security issues that the CISOs have to dust off the "we take your security seriously" speech. So I know I don't think at all you're trying to send a pessimistic vibe here or saying that software is going to fail. We have to accept security problems. But I'm curious how then, what does resilience, let's explore that relationship between resilience and security. How can we build better resilient systems that we're not forgetting what that top 10 list might tell us?
I very much view security as a subset of resilience, because with resilience, failure can take all sorts of forms. Attacks are one of them. I really actually think it's a very optimistic vibe, because it basically says, sure, failure is going to happen, but we can recover from it. We can make sure the impact is contained, and we can make sure that we're better prepared for failure in the future by being able to learn from the experience. So I think in the context of security, I personally don't think that dust off the security is very important, kind of like the airlines being like, your safety is important to us, right? That's not very effective. There's very limited evidence that kind of like training and awareness is actually resulting in better outcomes. What does result in better outcomes, though, is not sweeping things under the rug, not trying to fix things with training, not blaming human error, but instead taking a very hard look at the problems, at the design, and looking at all the potential contributing factors in an incident, being able to untangle like, hey, maybe this design is confusing for developers. Maybe there are more bugs because right now our vulnerability scanning is taking 4 hours and they need to ship code faster than that. Like really looking beyond just pointing fingers and blaming a human and understanding, again, all of the interactions in the system, whether that's machine to machine or obviously the humans interacting with software and systems and everything else you have in place.
Yeah, and it's very interesting that already you've started off actually focusing on the human aspect, the social aspects and feline aspects of the as we hear cats in the background of the of engineering. And so I'm curious, if we talk about security chaos engineering is the title of your book. I don't think we have engineering chaos. The order of the words there is possibly important. What does it mean? How do we are we engineering around chaos with chaos? How are people approaching this?
Listen, I'm going to be super honest. If I had a time machine and I could wield enough authority, I never would have called it chaos engineering. I think it's a recipe for not getting adopted too much in organizations. And when we see across other complex systems domains, whether that's healthcare, aerospace, financial services, they all call it resilience stress testing. And I think that's much more descriptive of what we're talking about. The idea there is we're very much simulating adverse scenarios and adverse conditions to see how our system responds end to end. So it's not just like input here, see like a true false outcome. No, it's very much looking like, let's say you want to inject the adverse scenario of a misconfigured port. Okay, you are certainly looking to see did the firewall detect or not, but you're also looking to see if the alert was received by the human and if it was actionable, if it actually resulted in real recovery. And you're looking to see, did it show up in your logging pipelines? Did it show up in maybe like the configuration management tool? So again, it's really about that end-to-end picture of system behavior. So the chaos is really just you're injecting that adverse scenario, you're simulating it. You don't have to do it in production either. The whole goal is to fix things in production, not break them. So I think, again, with chaos, just think of it as like chaos is already happening in your systems. It's just the nature of any sort of complex beast. So what you're trying to do is simulate that chaos ahead of the real thing happening. So again, you can better prepare for it when something goes wrong.
So then who does that simulation? Are we talking, you've also resisted saying shift left so far, which
Yes.
I don't think is related to this at all. So who are we transferring, to use a synonym, the responsibility for, doing this chaos, doing this non-production type of testing of, adversarial, making things go wrong?
Yeah, shift left, I feel like, is often just shifting the security burden left without really changing how anything's done. I feel the same way with DevSecOps. I joke that it's like security's like Kool-Aid Manning into DevOps, which is not very productive. No, instead, we very much want to encourage more decentralized accountability and ownership. The reality is, let's say you have a database team and like the billing service team in an organization. Would you expect them to be able to like review each other's code and like make decisions? No. Like we would find that ridiculous. Maybe they could spend like a few months, maybe if they're really good, a few weeks getting up to speed. But that's what's happening in security programs all the time. They're the equivalent of like the database team saying like, thou shalt not to the billing service team. And they're just like, wait, you don't understand our system context at all. So it's very much respecting that there's always this local context that matters, especially when it comes to security. There's really no one size fits all. And it's not to say that we just let people get away with like doing nothing. In my experience, developers rarely just want to, is what I call YOLOsec all the time. When they do, it's normally due to production pressures. So they're being pressured to like deliver more faster, and it's fine if they cut corners. And by the way, security is not the only corner they're cutting in that case. But that's very much encouraging like these engineering teams to think about, okay, what kind of adverse scenarios are worth simulating? And I have like a whole bunch I can certainly say and do say in the book around how you can brainstorm these adverse scenarios. And software engineers, in my experience, are really good at kind of putting on their black hat, so to speak, and like thinking nefariously about how they would like abuse or infect their system. So I know it's a kind of provocative approach for a lot of security teams because they like the idea that they're the central arbiter and the gatekeeper, and they wield with the iron fist or whatever you want to call it. But it saves a lot of work for you on the security team because you're able to offload a lot of these responsibilities and you can be more strategic, which is what everybody wants.
Indeed. And I think, I'd love to hear maybe some hints or what sort of those flavors of what could go wrong, look like, because it sounds like threat modeling, which often AppSec teams, start with your data flow diagram. And suddenly it's crickets because nobody has an up-to-date data flow diagram. And nobody wants to create that because it's honestly not that interesting. So how do we encourage developers to take this on? As you rightly point out, perhaps they know how best to pick apart their own apps, but to do so in perhaps a structured way, in a way that isn't just a complete burden on them.
Yeah, so I definitely recommend data flow diagrams, and most software engineering teams will want them for other purposes, sometimes even just compliance-wise. It's going to be required. You can also generate some of those automatically through things like distributed tracing, which is quite powerful. And again, talk about in the book because it's something that I see really overlooked by security teams. But I think you're right. We talk about decision trees as a form of threat model that's a little more active that you want to layer with things like data flows. But those are the basis of your hypotheses for experiments. If you're assuming like, hey, again, like with a misconfigured port, that's a way for an attacker to get in, or even like, your logging pipeline goes down. That's kind of a problem for any incident response. That's absolutely an adverse scenario that you can inject. And we actually have a case study from Open Door about precisely how to conduct experiments related to your logging pipelines. There's really no end of what you can do. My favorite is actually time traveling on a host. So actually changing the host time forwards or backwards as an adverse condition, because as anyone who's worked with software knows, like time is hard. It fails us every day.
Wibbly wobbly.
Yeah, even things like leap seconds can be a crazy, results in really crazy effects and interactions. So there's really no end. I created like tables and tables of potential experiments. So it's your chance to be a bit creative. And I like to put it as you're actually creating myths. Myths are something very powerful throughout human history. People think in stories. So every time you conduct an experiment, it's your chance to kind of play poet, get creative, conduct the experiment, and then write that down. Make sure it's in an accessible narrative that becomes your company's new kind of like mythos that, how myths are meant to teach us and impart important lessons. We can do the same thing with experiments, which is a lot of fun.
No, yeah, I love how we've embraced so far the references to basically scientific method, testing our hypotheses, as well as embracing the mythology and as well. There is then this aspect, it sounds like these are very much interconnected systems. So developers, maybe they are logging events, but developers for a particular web app might not be responsible for the logging infrastructure. They might not be responsible. They're probably not responsible for the incident response. So is a lot of this predicated on the interconnection of systems as more so than building the web app itself? How does that look from, an internal view from a developer's perspective to external and who they have to interact with in the company?
Well, with logging, what's interesting is you do actually have to define it during development. Developers do have to set things like log levels. And so one thing that I really try to encourage in the book is to think about those second order effects. And what will an incident responder need to be able to successfully recover your system? And that's the importance of making sure software engineering teams have aligned metrics like time to recovery. so they don't forget the ops part of things. But I think there's a general principle. I call it the effort investment portfolio. Because I have a finance background, so I like thinking about effort as this finite capital you can invest in different opportunities for a return. So we want to be very careful about how we invest our effort. One of the things that you start to see, though, is what I also like to call the thermodynamics of effort. So effort can really neither be created nor destroyed, right? So you're just shifting effort around. This is where the shifting happens. And I think shift left is very much just shoving the effort earlier in the process onto a different team. So with this, you could save effort during development by not thinking about logging, but then you're requiring more effort down the line, right? And so it's really truly thinking about that end-to-end picture of the system where, resilience is a verb. That's something very well documented kind of by resilience scholars, and we see it every day. And our systems are living, breathing things in effect. They change all the time. We can't think about it as, static components that maybe talk to each other. We have to think about it as these interactions and these flows and how they have like a life cycle, which requires a bit of a mind shift. But I think once you get into that mindset, it's not too difficult. So that's what I really hope to inspire in the book, is thinking about software more like an ecosystem and managing it accordingly.
It's an interesting analogy. Someone wrote in a blog post in the last year or two, and it might have been you, I can't remember, but talking about technical debt, and actually that same concept of it's not actually debt, it's more of the choices you make of where do you actually want to put that investment, using your word now, of like, that seems between that and the myth that's going to resonate with people, that they're able to actually wrap their heads around that a little more easy way.
Yeah, I think there's a lot to be said for things like technical debt. I think, again, when you start to have the mindset of humans generally are trying to do the right thing, which I think a lot of behavioral research shows, we're generally altruistic, for instance. We're not really that ruthless homo economicus that is portrayed a lot of the time. Once you assume that and you start really digging into the factors, is technical debt really just because people are lazy or they don't care about software quality? Or is it because the way they get rewarded is by delivering quickly, even if it's shoddy, and is management and up setting expectations that quality doesn't really matter based on those incentive structures? Do they tacitly punish when people invest in software quality, which maybe requires a bit more time, or they're, shipping things a little more iteratively? You have to look at all those factors. And I am not going to pretend like my book completely solves how to fix incentives. I think there could be a whole textbook just on that topic, but we still need to be aware of it. And certainly what we shouldn't be doing, which I see all the time in security, is calling people lazy or saying that they don't care. There's nothing less constructive, nothing that will poison that relationship more than having that kind of mindset.
Yeah. I always love inverting the developers don't care about security to does security care about development?
Precisely. Yes.
How would you feel hearing that? Or do they know? And so speaking of, I'm very glad that we started off on talking about people, talking about behaviors, because this is what transfers everywhere, regardless of language, regardless of tech stack, et cetera. But I don't want to ignore our tech stacks. And I'm curious, how do you in the book approach the idea of security by design, or are there, are there still technical considerations or design patterns that the teams can go after that build resilience?
Absolutely. Absolutely. And chapter 4, in fact, has, I think, nearly 80 pages just of basically technical opportunities that you can pursue to improve software quality, because I very much view security as a subset of software quality. High quality software is secure software. And I know the recent guidance from like CISA and a whole consortium of intelligence agencies basically mimics that idea that we do want that security by design. I also talk about in chapter 7 specifically on what I call platform resilience engineering. I talk about the ice cream cone hierarchy of safety solutions, and at the very top is eliminating hazards by design, and after that it's reducing hazardous methods and materials by design. So C code, for instance, I like to think of it like lead. It was really useful for us. It accomplished a lot, but we kind of know it's making us sick now, and especially as it accumulates over time, it's really not good for us. So we should use other raw materials instead. We should try to transition more to memory-safe languages, which luckily memory unsafety is actually pretty unpopular in languages. So there are lots of opportunities for that, and I talk about that as well. But there are so many opportunities, even like type systems. we often think about that as something that resists change, but actually can be a fantastic way to preserve possibilities for refactoring in the future. So I'm trying to teach the security community more about these opportunities that maybe aren't strictly security things as we think of them, but again, come more from the software quality side, but that can absolutely still improve our resilience to attack. So there's just tons of technical stuff we can do. And there are two kind of key qualities that we should pursue. One is looser coupling. So you can think of that as more like independence of impact, and then also linearity. Trying to make sure we reduce the space of baffling interactions with our systems or in our systems. Loose coupling is much easier to achieve than linearization because it turns out we like building complex functionality. It's kind of difficult to remove the complexity from the complex system, right? But we can kind of nurture this looser coupling through things like isolation and sandboxing. And I actually, even though we talk about both of those things a lot, I actually think that we don't think about it enough and we don't implement it enough because we often so much think about kind of what you described. You have this long list of vulns, you have to vuln scan, you have to train the developers about the vulns. It's like, or we could just contain impact. So even if an attacker exploits a vuln, it gets them nothing. That sounds a lot more powerful to me and like a lot better use of our effort.
And we've seen that with the browsers have moving to that. The Blast Doors, the project that Apple did to help protect iMessage. So, but it seems off the top of my head, I can only maybe get half a dozen examples that also, unfortunately, are related to C code and memory unsafe code. I'm curious, are there other resources where you would try to teach these by example, or not to say that we need more awareness, because I very much appreciate what you were saying at the beginning. If we just have more awareness and more awareness, after 20 years, maybe we've seen that doesn't necessarily help. But there has to be, in addition to your book, how do you push your resources? How do we do that? How do we approach this for perhaps maybe a better way to ask my very long-winded question? Junior developers, we need to introduce them to these concepts. How do we teach them?
Yeah, that's one thing that I was trying to accomplish in the book is both teaching security people about software and software people about security. And especially for software engineers, the idea that a lot of what they're doing already, again, for software quality or reliability, are things that benefit security, either just out of the box or if they extend it in different ways. So performance isolation is something that they care about. They want to make sure that if there's some sort of fault or issue in one component, it doesn't cascade. Isolation in that sense can just look like using a serverless function instead, or containers, or virtual machines. It could be using like AWS security groups. It could even be something like syscall sandboxing if you want to, or like the capability safe model with like WebAssembly. There's a whole host of things when you think about isolation that you can actually implement. A lot of it is in the underlying architecture itself. But I think what's interesting, again, from the software engineering space is thinking about, okay, maybe we already want isolation, both temporal and spatial, for these performance reasons. How can we think about how it benefits resilience against attack too? And that, I think, is the powerful shift, is no longer thinking, well, it's the security team's job to figure it out, because there's so many opportunities, again, by design that we can pursue. So to me, that's the real thing, is not necessarily teaching them like, hey, here are all these separate techniques for security. It's just, hey, here's how these things you already want to learn and need to learn and want to implement can apply to security as well. And I think we'll get a lot farther with that tactic rather than like, here's your separate siloed like education program, which it's just not as sticky, right?
No, I think you mentioned you mentioned one metric in particular, and you mentioned DevOps and the colorful DevSecOps trying to sneak their way in. There's also, I'm going to throw in another SRE in there too. It's another development model. I think they talk about resilience too, or at least uptime, right?
Definitely.
Are these, does an SRE do some concepts there work well within this idea of resilience, security, chaos engineering? What are some other ways we could, developers could adapt or basically imitate?
Oh, absolutely. SREs are one of my favorite audiences, actually, because they get so excited about all this stuff. Because again, they see, oh, wow, we already, let's say, want like distributed infrastructure, immutable or ephemeral. And you're telling me that helps with our resilience against attacks as well? They're like, sign me up. They just get so just genuinely excited about it. There's a lot of overlap between SREs and security, but because of that historical animosity, which again, to your point, a lot of times security people haven't cared about reliability. They're like, sure, we'll install this security tool that causes kernel panics in production. Like, that's fine. And SREs are like, that is absolutely not fine. We'll get fired. So there's a lot of tension historically, but there's a lot of overlap. Like, I joke, like, SREs don't want developers like yeeting around in production either. They want things to be stable. They want things to be reliable. And ideally, they want to, again, contain impact from any sort of incident, whether that's because of an attacker or just because of like software being software. So it's actually chapter 5, I talk a lot about that overlap and how a lot of system signals can be valuable for security as well. So hot take is I actually think SREs, if anything, might be the better team to be running a lot of this like software security stuff or application security, just because then they can treat incidents like incidents. They can make sure that all the logging pipelines and observability are in place. Again, all they have to do is just extend that a bit to security. And one really powerful thing that SREs do as well is they build tools. They treat or they approach their problems like software reliability like it's any sort of user problem that it needs to be solved with software. So they're not just applying bolt-ons all over the place. They're very much thinking like, how do we build tools? How do we build systems that can help solve this problem? That is not something that most security teams are equipped to do. They should be. And I'm hoping this is a bit of a wake-up call for them. It's like, hey, if you want to secure software systems, you kind of have to understand software and you have to be able to work with it. So I think SREs should be absolutely a natural ally. So if I'm a security team and I don't have a great relationship with SRE, this is when I start figuring out, okay, how do I do some favors or otherwise like build a bridge, because SRE can help you a lot with making sure, helping secure your software and thinking more about those opportunities to pursue security by design.
But let's take I completely agree with you, what you're just saying, but let's take a tiny step back from that, because one of the problems I've seen in some parts of the world is an org which hasn't embraced SRE yet. So how do you, because it's I think once you start going down this path, a lot of these things sort of click in, like the way you're describing, especially those guys that light up when you see it. But for those orgs that haven't even figured out yet that they need that SRE team, or why that's better than just having the dude who's monitoring on a laptop, how do we, have you figured out a way to do that next jump, that next layer up?
I think it's something that naturally emerges once you care about availability and uptime at all. I personally don't think you even need to call it SRE. Even at some of the, like you said, there's sometimes like a guy with a laptop. There's usually someone who's either like infrastructure engineering or something like that. You can still embrace the SRE principles. Like, I certainly don't think we have to adhere to like anything too specific, as long as you're kind of like aligned with the underlying philosophy. I also think potentially if there is buy-in for security, that's an opportunity to start getting wins on the reliability front. Because guess what? If you're able to stop an outage, that's tangible revenue. That's something that's very tangible and good for the business. And I know that's something security leaders are constantly in search of, is how do we actually prove value to the business? So if your business isn't necessarily down with creating a separate SRE team, and whatever kind of like IT you have in place isn't pursuing it either, maybe you can start adopting it. And again, it'll even give you more flexibility in the future if you do want to expand and you want to start creating, what I call like security paved roads and other tooling that can help by design. Just adopting that SRE mindset is going to pay dividends. So that would be my recommendation. I think there's definitely a bigger problem if a company doesn't care about uptime or outages, but it's still wrecking them. I think that's kind of in the realm of like executives are clearly not aligned, and my book certainly doesn't have recommendations for that specifically. I'm not sure, like, consult the eldritch gods and sacrifice, crystals and hemlock and whatever else. I don't know. It's a tricky problem.
Yeah. We Beltane, it was a week ago, so we can't dance around the maypole now and save ourselves. Yes. But you were mentioning uptime. I do like to ask about metrics, and I'm curious, is uptime maybe is availability. So it's part of our CIA triad, but is that the only thing? Like, how do we also show success? How do we show resilience and point to something other than just how many nines we've had for our application?
A lot of it is about recovery and almost like the derivative in recovery. Can you show that you're actually improving? I love the DORA metrics, actually, as metrics for resilience. And I think they're fantastic for security because they think about like how long does it take to implement changes, basically. They have 2 metrics basically around speed. And the same applies to security. Like, if you can't deploy a patch quickly, guess what? You're going to have an Equifax-like problem. And it's the same with any sort of security change or security fixes. We want to be able to move quickly, but a lot of times what we see in security programs is the opposite. They're optimizing for like mean time to failure or between failures, which for a whole host of reasons that people have already discussed is like a terrible idea. Curtails innovation, and it's just unrealistic for all, again, the reasons we talked about, because failure is inevitable. So I think aligning more to like, okay, speed is actually good for security. That's a good start with metrics. I will say there's like a total nerd fight in resilience land across different disciplines about what metrics make sense. Part of it is because in a software, we actually have it easy. It's a lot harder to measure the resilience of like a grassland ecosystem or an urban water system where you can't conduct things like experiments, because it would be really unethical to just like simulate a hurricane and then see like, oh, what if we play around with like more storm drains or shutting some of them off? We can't do that. So we're actually very privileged. But some of the metrics we can do are in combination with things like chaos experimentation, that resilience stress testing I mentioned, because you can actually start to see over time, like, okay, do we respond to failure faster? Are we recovering with more grace? That could mean that the impact of an incident is less over time. Are we just, again, stopping it in the first place? Do we have more like system signals that are filling in the picture? There's so much we can look at. We can even look at things like burnout. We can do surveys of the human responders to see like how stressful are incidents over time. Does it seem to be getting less stressful over time? That's a fantastic signal, because burnout plagues our industry. So there's like a whole host of like signals and metrics we can look at from a variety of facets to measure system resilience, because again, it's this end-to-end socio-technical picture.
And that might be the first time that we've heard on the show a reference of people-oriented metrics, avoiding burnout. So I just wanted to really highlight that and underline that socio-technical, you're hitting, I think, 50-50 on both of those parts of that word. I like that.
Definitely. And I recommend Dr. Forsgren and her compatriots, as they like to say, created the SPACE framework for developer productivity. This is something where, especially if you're adopting more of the software engineering approach to your security, you want to measure for your own employees. But importantly, I love thinking about the opportunity cost of what we implement with security. And so if you implement something new, you can actually look at the SPACE framework, see these developer productivity metrics and see like, hey, is developer productivity going down when we have all these like new fancy, like, I don't know, like VPN or access requirements? And you implemented zero trust that requires them to completely relearn their workflows for accessing their resources. Like, is productivity plummeting? That's really good to measure too. So I would love if more security teams adopted that mindset of like, hey, we should be looking at these developer productivity metrics as well.
Yes. How can security just be more secure without getting in the way, and to avoid all of the eye rolling for those of you just listening, as we mentioned zero trust or shift left and all of the buzzwords that should go away. And one of the reasons I want to use that as a segue, Kelly, into talking about communication. One of the things we love to highlight are blog posts, short essays, short articles that explain a problem, walk through an exploit that might be in C, but really talk about the threat-minded thinking, attacker-minded thinking. You have done, well, you blog, but you've got a book. That's a few thousand more words than an article. Tell us a little bit just approaching that. What have you learned about that you would also share as just ways to be a better communicator, written or otherwise?
Oh, yeah. I think about this a lot, probably too much. I definitely overthink this. Part of my personal blog, I try to have fun. Sometimes that means that I'm writing blog content that is longer than most modern attention spans, which I kind of think, well, train it better, because, I almost resent the idea that like 4,000 or 5,000 words really is long form. It's like, that's not even novella territory yet. Let's be real. No. I joke, but the old internet that I think we all were kind of fond of, it wasn't these like tiny sound bites. It was generally like people nerding out on something in depth. And I very much like that vibe. But realistically, like, you need to have a variety of content, both short form and long form, so people digest in different ways. Part of the reason why I love doing podcasts as well is because some people prefer consuming information through auditory means, right? Not just the written word. And it's the same thing with like video presentations. So I think if you have something you're passionate about sharing, which I definitely do, I feel like I have too much passion in most cases, then you want to approach it from like a few different angles. A big thing, though, a secret trick that I reveal is what I call the poop NATO. which is very eloquently named by me. But the idea is, you know that whatever you're about to put on the page is totally crappy, but you just get it out. You just stream of consciousness, whatever you want to say on the topic. You accept that it's just going to be terrible. It's going to be embarrassing. But you put that aside and you're just like, I just have to get it out on the page. And that's how I start everything. I just let it be word salad to, whatever extent it is. It's, by the way, almost always better than whatever terrible expectations I set. But by setting those really, really just like the bar is in the Earth's core expectations, then you're always going to surprise and delight yourself and get more excited about polishing it up. But so many times I see people really stuck because they want it to sound like erudite and very polished from the beginning. You're never going to get that. So just poop NATO it, let it sit there in its poop NATO form, and then come back to it and figure out how, again, even if it's like a little bit every day, how you can just refine and polish it. That's also how I wrote the book, was just that kind of like poop NATO, stream of consciousness, then refine, get feedback, and try to polish it up.
And I love that approach too. It's very intimidating just to stare at that blank page. It's a lot easier to take away words and just listen. How do these words sound like? Would someone actually say these words out loud, or do they just sound like that stilted, leather-patched Oxfordian professor, which I'm not going to pretend to do an accent for? You said that there was a lot of stuff that, the book had to shrink over time, perhaps.
Yes.
Are there any special surprises or anything extra? What did you have to cut that was a little bit of a tear to your eye?
There were some references I had to cut, both finance as well as literary. It turns out that I have more of a literary style than I assumed, because some people have amazingly read the book and digested a lot of it already, which just fills me with joy. And I'm not someone very easily filled with joy. My heart's very icy, so this has melted it a bit. But one thing that stood out is it apparently doesn't feel like a typical tech book, because I do have references. Even the quotes at the start of the chapters are like Virginia Woolf or Robert Boliano. Like, there are a lot of incredible authors. But I think it's because I have this cross-disciplinary mindset that there's so much we can learn even from fiction. My resilience journey actually started out because I read a book on earthquakes. And the author, she talked about how the fact that a building doesn't care if an earthquake was predicted or not. It's just, it either withstands the shaking or it doesn't, right? And to me, that's like
seems
software,
so obvious,
right?
But yeah.
Yeah, software doesn't care if we, did all, this drives me nuts. We did all the like fancy math trying to predict like attacks and whatever else. I know the FAIR methodology is precious to many people. Sorry, I'm calling your baby ugly, but our software doesn't care if it was predicted or not. Either it's going to get pwned or it's not. Either the impact is going to be terrible or it's not. So again, I feel like there's so much we can learn from all these different areas that I think that's really comes through in my style. So a lot of it that had to be taken out was some of that literary stuff. And I analogize something to financial crisis, and my lovely technical reviewers, they were all amazing. They were basically like, yeah, I don't follow this at all. This is clearly like really exciting to you, but it's not to me. No. So that's also the value of having people you trust to also tell you when your baby is ugly. So.
Well, I think what your message, I'm hard pressed to find anything in your messages so far, the podcast, to call ugly. So thumbs up from this perspective. As we do, I do want to draw out that perhaps literary, technical, socio-technical aspect with one last thing. We always ask our guests to describe AppSec in 3 words.
Yes.
And we're really curious how you're going to approach this.
I'm going to approach it, again, through the lens of complex systems, and in particular, how complex systems thrive. So it's adapt, learn, and evolve. That's what I would suggest.
Oh, love it. And on the theme of scientific method, too. I love it.
Exactly.
So we'll have links to your book. We'll have links to your blog so everyone can go read what you've been doing. But perhaps somebody wants to go listen to how you present as well. What's coming up in the future for you? Where can people find you?
Yes. So I have, fingers crossed, quite a few talks coming up over the course of the year. The next big one is in a few weeks at Go to Chicago, where I'll be talking specifically about what I call the resilience potion recipe, which is the 5 ingredients that we can pursue in this talk, it's specifically during when we're developing and delivering software that can help us sustain resilience. So that, I think, is the week before Memorial Day. I can't remember the exact date. Yeah.
So coming up soon. That's wonderful. Thank you so much, Kelly. This has been a wonderful conversation.
Thank you. Yeah, fantastic questions.
Enjoyed this. Want to say thank you to John and thank you to all of our listeners. Remember, this week in place of the news segment, we'll be running 2 interviews from last month's RSA conference. Thank you for joining us. Please subscribe, hit that like button, check out the show notes. And speaking of chaos and things that aren't chaos in order, check out Golden by Parallels. Stick around for the RSA interview segment. We'll see you next time on Application Security Weekly.